Morning students, in today's lecture we will learn about the geothermal energy, their types, where they are found, how they can be used for various energy conversions. So let's start. Geothermal energy, mainly it's a form of renewable energy having a source of natural heat inside the earth. Mainly it is geothermal energy is the energy which is stored inside the earth, and we are having some locations where it can be used. We can see some hot water steam generator wells, as well as the hot water wells. So these are example of geothermal energy. It is renewable energy since the earth's interior will continue to energy having high energy density. It is inexhaustible like solar or wind energy, because the high heat of the earth is very much high, and the heat is being transferred outside. The geothermal energy in the form of heat energy can be utilized economically and efficiently for power generation and other applications with the existing available technologies. So the amount of thermal energy within the earth is very large. Useful thermal energy is limited to certain sites only in the world because of the feasibility of access and extract heat. The heat in the earth is having heat energy is very large, but we cannot collect the whole heat from the earth, and we are having a very fixed locations where we can access this heat, and that can be utilized up to a certain level. These sites from where the thermal energy can be extracted are called the geothermal fields. The commercial utilization of this energy started first in Italy in Lardero in 1904, Cardell 1930, Iceland 1930, and other part of the world by 2000. Mainly first it is being used by Italy, and it is being followed by Iceland and other part of the world, but it's primarily got focus in 2000. In India, about 50 shallow wells are drilled for steam production in Jammu and Kashmir belt. The thermal springs are found in different parts of India, that is Himachal Pradesh, Maharashtra, Cambay of Gujarat, Uttar Pradesh, and some parts of Bihar and near Jawai in Assam. What is the origin of geothermal energy? How this energy is formed, or how can this can be used? The Earth's interior having mass of hot liquids, gases, and steam that is cooling slowly, and the temperature of the Earth's core is estimated to be about 4000 degrees Celsius. The average geothermal heat dissipated from the land is about 0.06 watt per meter square, as compared to solar heat energy of 1 kilowatt per meter square. Below the solid crust is the molten mass called magma, which is still in the process of cooling. Sometimes we see volcanoes which erupts magma, and it want to get cooled because of the high temperature. It comes to the upper surface of the earth. The earth's vibration causing the magma to come near the earth's surface, thus cause active volcanoes, hot springs, and geysers water exist. The hot magma near the surface solidifies into igneous rock. The heat of magma is reflected upwards into this rock, and groundwater that finds its way down to this rock through fissures in it, which will be the heat of the rock, or by mixing with hot gases and steam emanating from the magma. The heat water will then rise upward by convection into porous and permeable reservoir above the igneous rock. It is covered by the layer of solid impermeable rocks. It traps the hot water in the reservoir called hydrothermal fields. Means due to the magma which is being erupted, it holds the heat and it is the main source of energy which we got from the geothermal sites. The well made by drilling holes in the upper crust in the region of geothermal field can be used to trap steam for use in a conventional power plant. The steam originating from magma is called meteoritic steam, largest source of geothermal steam. From the figure it is clear, this is the magma and it precipitates sheets, and this is the igneous rock, and this is the porous rock where hydrothermal field, mainly we consider this as a hydrothermal field, and it mainly hit the solid impermeable rock, and from some pores it got out as a form of steam. We get this hot spring from a well, we construct it manually for power generation. Classification of geothermal energy resources or systems. Geothermal resources vary in temperature from 30 to 350 degrees Celsius and consist of dry, a mixture of steam and water or hot water only. The water is the transfer medium in order to extract geothermal heat from the earth. Table given below lists the basic technologies normally utilized according to the resources temperature. Here you see the table. It's a reservoir temperature, reservoir fluid, common use, technology commonly used. For high temperature reservoir where 180 degrees Celsius, that is greater than 180 to 200 degrees Celsius, reservoir fluid is the water or steam. Its common use is power generation. We use such technologies, that is flash steam, combined flash and binary cycle, direct fluid use, heat exchanger, heat pumps to get this generation, power generation. Medium temperature reservoir, it is have up to that is 100 to 180 degrees Celsius, and the reservoir fluid is the water only. The common use is power generation, and the technology used are binary cycle, direct fluid use, heat exchanger, heat pumps. For low temperature, the reservoir fluid is the water, and the common use is of direct use. The technology which are being used are direct fluid use, heat exchangers, heat pumps. The geothermal energy system is classified as mainly into three parts: hydrothermal or dry rocks, we call it HDR, geopressurized system. The hydrothermal, we call it convective resources also. These resources are located at shallow to moderate depth of 100 meter to 5 km, and in such water is heated by contact with the hot rock, and high pressurized steam is generated up to about 350 degrees Celsius. These resources further divided into following categories depending upon whether steam or heat water is the dominating product. So we have water dominated dry steam fields and the liquid dominated wet steam fields. Now we will study about the dry steams, that is vapor dominated systems. In the system delivers steam with little or no water of high pressure and temperature up to 200 degrees Celsius. This steam is used to generate electrical energy by electromechanical energy conversion. The steam extracted from such fields may contain some amount of water and solid particles. Those are removed in a centrifugal separator. This pure dry steam is then directly supplied to a steam turbine which is coupled to a generator. The condenser is used to condense the exhaust steam from the turbine for recirculation purpose of cold water. This cold water is either sent to the chemical recovery or it is re-injected into hot field with the help of condensate pump. The main drawbacks of these plants are the presence of corrosive gases and abrasive material which causes the environmental problems. This is the particular figure of dry steam power plants where the production well is used for using dry steam, and it is a separator. This separator is used to move the steam turbine, and it is a generator. Mainly the steam is used for electricity generator, and this condenser is used for hot water, convert this cold water into the hot water. This particular steam is then concentrated and be reinserted into the injection valve. Next is the wet steam or liquid dominated systems. The temperature range of such fields is in the range of 100 to 350 degrees Celsius, and these fields deposits hot water without much amount of steam. This can be further classified and explained in the following categories. The first one is the high temperature wet steam system. The high temperature wet steam system having resources temperature above, that is above 180 degrees Celsius, suitable for power generation. The temperature which is higher than 150 to 180 degrees Celsius can be used for power generation. In such system, the hot water with steam at high pressure and high temperature is extracted by the deep wells drilled into the grounds. This hot water from underground from a depth of about 1 kilometer, that is point A, at high pressure about 35 to 40 bars reaches the well at point B at low pressure. This process produces two-phase mixture having the steam of low quality. This mixture is fed to flex chamber, brine separator or brine separator, which separates dry stream from brine, which is collected from bottom. And this dry stream which is collected from the bottom is supplied to the steam turbine, which is coupled to a generator, produces the electrical energy. The hot brine is re-injected into the ground along with the steam concentrate from the concentrator. So this is the figure. We use the production well. This is the separator. Separator will separate the steam from the brine, and this steam is used for the electricity generator, and the brine is then condensed to the condenser system, and this is being reinserted into the geothermal zone by a injection valve. Low temperature or binary fluid system. These hydrothermal resources are available in the temperature range of 90 degrees Celsius to 170 degrees Celsius, which is not suitable for production of two-phase mixture of steam. In such situation, to utilize this geothermal heat, a fluid of low boiling point, example isobutane, is used under pressure in a primary heat exchanger. The fluid vapor generated is passed through a turbine where it expands, and this mechanical power of turbine is converted into electrical energy by a generator. The exhaust of the turbine is passed through a heat exchanger and condenser where it is cooled and then condensed. The thermal fluid, after transferring heat, is re-injected through a valve into the ground. Same figure we know from the production well. We get the heat exchanger. It uses the vapor. It changes the vapor into the steam turbine, which is used for generation of power. And this generator, the regenerator, can be used for converting cold water into hot water, and after condensing, it is reinjected into the wall. Hot dry rocks, HDR of petro-geothermal systems. Hot dry rocks receives heat energy from the molten rocks, that is the magma. These reservoirs are artificially created by fracturing deep compact rocks up to depth of 8 to 15 kilometers by hydraulically or chemically or by nuclear explosion for injecting high pressure water. Means we fracture the stone, that is magma or dry rock, and up to 8 to 15 kilometers, and we can use any mechanism, that is hydraulical or chemical or nuclear, to inject the high pressure water, and this high pressure water is then converted into steam, and it is being used for generation of electricity or for many other purposes. The water is pumped into the fracture well, injection well, and withdrawn from another well, that is the production well, to extract heat to generate steam from power production. To prevent mixture of water in the reservoir, the depth of the production well is kept slightly less than re-injection well. Means both the water will not meet in the reservoir. To avoid such a situation, we kept the depth of production well less than the re-injection well. Here from the diagram we can see that this is the production well and this is the re-injection well. We pour the water to the injection well and this is being when heated up can be collected from the production well. This pump will transfer the heat to the heat exchanger and which is being used to the power plants. Geopressurized system. These reservoirs were developed by sand deposits carried down by rivers and entrapped brine and natural gas at depth of 4 to 6 km and are located at different levels and at different places. This system comprises of heavily compressed sediments that contains heat, methane and pressurized hot water. When well is drilled in this zone, the reserve energy comes out in the form of high pressurized water having temperature about 160 degrees Celsius. Heat and natural gas methane, which are useful for power generation. These sources have been found in offshore wells in Texas and US Gulf Coast areas. Now we will understand the main features of geothermal energy. The advantages of geothermal energies are it may be used in both energy supply with power generation and direct heat use. It can be used in the power generation and it can be used directly for conversion of cold water to hot water and for steam for various other purposes. It is an inexhaustible source of energy. It is almost free of pollution, independent of weather condition, more reliable source of power generation than other renewable energy sources. Disadvantages are it can cause corrosion, erosion and chemical deposition due to the presence of sufficient amount of CO2, CH4, N2, NH3, H2S. We know the H2S, it's the nitrogen sulfuric acid. Noise pollution because of well drilling, centrifugal separator, proper refilling of water is necessary. Here the refilling of water is very much necessary. This is the main disadvantages. It causes settlements of land, means land can change its form. Life of plant is low compared to conventional power plants, because we don't know how much energy can be utilized from the geothermal point. We didn't know the exact amount of heat there, so its life cannot be sure. Its life is not fixed. Environmental impact. Some part of the condensable gases CO2, H2S, NH3, CH4, N2, NH2 and radioactives are escaped to environment at various points and cause air pollution. There is possibility of seismic disturbance because of extraction and re-injection of saline. Water pollution of rivers and lakes is a potential hazard as geo water contains high amount of dissolved solids with silica. The heat energy of turbine exhaust steam is rejected to atmosphere in cooling towers. It causes dense fog, increasing moisture and other environmental hazards. In such systems, soil erosion takes place due to drilling of wells in geothermal fields. The exploitation of geothermal energy may cause earthquakes also. The potential of geothermal resources in India. In India, about 150 non-geothermal sites which can be produce working fruits up to 170 degrees Celsius. Main location of such fields are geothermal fields of Puga, Chumagathang Valley in JNP. A pilot project for space heating involved construction of a sheet at an altitude of 4,000 meter and 44,000 meter in Ladakh district, Jammu and Kashmir, and using steam at 125 degrees Celsius. Manikaran, Himachal Pradesh, the second location. This project cold storage plant has been recently commissioned by the collaboration of Geological Survey of India, IIT Delhi, and HP government. Third location is the geothermal field of Beas and Parvati valleys, Himachal Pradesh. Beas and the Parvati valleys are well known for their hot springs in Kullu districts. Himachal Pradesh, the spring temperature varies from 22 degrees to 59 degrees Celsius in Beas and 21 degrees Celsius to 96 degrees Celsius in Parvati Valley at an altitude between 1300 meters to 3000 meters. Other locations are Sohna near Delhi, Tuba in Gujarat. So this is the main diagram where the index 1 provinces that shows the Himalayan province, second is the Aravalli, Nagalucha, West Coast, third is the Gondwana, Sun Narmada, Volcanic Arc, Andaman province, and fourth location is the Deep Sedimentary Basin, fifth is the Radioactive province, and fifth is the Cratonic, sixth is the Cratonic province. Thanks for today. We have done for geothermal energy. In the next class, we will understand the MSD power plants and their material and its uses. Thank you very much.